So, well, if we look at this one, they say to us, industrially, vanadium metal V, which is used in steel alloys, can be obtained by reacting vanadium pentoxide with calcium at high temperatures. The balanced equation for the reaction is given. So we have 5 moles of calcium reacting with 1 mole of vanadium pentoxide in order to produce 5 moles of calcium oxide and 2 moles of vanadium metal. Now, during an industrial process, 31,850 grams of vanadium pentoxide reacts with 2 exponent 4 grams of calcium. And the first question is asking us to define the term limiting reagent. Well, of course, we understand it is the reactant or the reagent which is used up first in a chemical reaction. Right. Then the next question says, please calculate the theoretical yield of vanadium. And then the next one says, please calculate the percentage yield if 8.67 exponent 3 grams of vanadium is obtained. And I want you to realize they could have just said, calculate the percentage yield if this much of vanadium is obtained, without even asking you 7.2. So they could have easily made it an 8-mark question or 7-mark question, okay? Now, of course, we'll get to the percentage yield right now, but then I want you to understand, in order for you to find this percentage yield of vanadium, you need to first determine the limiting reagent, because we know that it controls the amount of product that is going to be formed. And we also know that we need to use the limiting reagent in order to determine how much of the product will be formed. All right? Now back to this percentage yield. The word yield actually means produce. So we want to know, what is the percentage of vanadium that we were able to produce? And you need to know, in order for us to find this, we need to know 2 things: the actual yield and the theoretical yield. Now the question is, what is the actual yield? Well, this one is the actual amount of vanadium that is produced. The one that we collect from the reaction mixture at the end of the reaction. In other words, the mass that we get maybe from the glass beaker or from whatever that we're using in order to conduct the reaction. The one that is actually produced. But what about the theoretical yield? Well, it's theoretical. It's the one that we expect to form, right? And science will teach you that expectations are not necessarily what you get in reality. Because every time you should know that what you actually get from the reaction mixture is less than what you expect to get. And every time when they give you this, for instance, if you look at 7.3, they say if 8.67 times 10 to the power 3 grams of vanadium is obtained, this is the actual mass that is obtained. The theoretical one is the one that you always obtain by means of calculations. That's the most important thing. And this is what I want you to know. You can calculate the percentage yield in terms of masses, meaning you say actual mass divided by theoretical mass times 100. But you can also do it in terms of number of moles. the number of moles actual divided by the theoretical number of moles. And of course, you can also do it using volumes. So don't always expect to do it by using masses only. Well, that's enough theory. So let's just go and destroy this one. Yeah. I hope you are paying special attention. Now, the first thing we need to do, of course, is to find the limiting reagent. And since we are given the masses of both our reactants, then we can easily do that, okay? As we explained in the previous video. So now we need to find the number of moles of calcium. And of course, we know that we take the mass and divide it by the molar mass. And of course, we said this is the first step, all right? Well, the mass is going to be 31,000. In fact, it's not for calcium, sorry. Calcium, it's 2 times 10 to the power 4. And we divide this by the molar mass of calcium, which we know from the periodic table, it's 40 grams per mole. So let's see how much we get when we say 2 exponent 4 divided by 40. Well, we simply get 500 moles. Okay, fine. Then we come back and find the number of moles of vanadium pentoxide. Well, of course, it's going to be the mass over molar mass as well. And the mass of vanadium pentoxide is given to us as 31,850. And this is divided by its molar mass. Now the question is, how do we find the molar mass of vanadium pentoxide? Well, if you go to your periodic table, you can see that the molar mass of vanadium V with atomic number 23 is just going to be 51. And here you have 5 oxygen atoms. So if you go to your calculator and say 2 times 51 plus 5 into 16, where you simply get 182. So well, if you now say that 1850 divided by 182, you get a solid 175 moles. Okay, fine. Remember, what you see here is the number of moles that are available at the start of the reaction for both of these reactants, all right? Okay, fine. So the second step is to find the number of moles of one of these two reactants that are needed to react with the other reactant. So now you need to decide, do you want to find for calcium or do you want to find for vanadium pentoxide? Well, let's find for vanadium pentoxide. So this is what we say. And the question is, how do we find the moles of this one needed? Well, it's very easy. We go to the balanced chemical equation and we relate calcium to vanadium pentoxide. Well, these two, they relate in a 5:1 ratio. So now we want to know if we have 500 moles of calcium, then how many moles of vanadium pentoxide do we have? Well, we take this one, divide it by that, multiplied by that 1. So when you say 500 divided by 5, well, you get 100 times that by 1, well, you simply get 100. So now you can conclude and say, well, the number of moles of vanadium pentoxide that are needed are just going to be 100 moles, okay? Okay, fine. So now it's time to make a comparison. So we are going to compare the number of moles of vanadium pentoxide that are needed versus the number of moles that are available at the start of the reaction, of course, to see if we have a change or we actually have a shortage of funds. Well, what we had at the start of the reaction is 175, and what we need is 100. So now we can see that we actually have more than what we need, okay? So this means vanadium pentoxide is an excess reagent, which means that calcium is the limiting reagent. Okay, fine. So that's the most important thing that we established. So now we can use our limiting reagent in order to calculate the percentage yield, all right? But to be precise, in order to calculate the theoretical yield, which is just the mass of vanadium that we expect to form. So let's go ahead and do that one. So it's going to be step number 3. Now, how do we do that? Well, we are just going to take calcium and we react it with vanadium. And we can see that according to the balanced chemical equation, they actually react or relate in a 5:2 ratio. So now, if I have 500 moles of calcium, then how many moles of vanadium do I have? Well, you say this one divided by that, you get 100, and you times it by that 1, so you get 200. So now we can see that the number of moles for vanadium will be 200. That's fine. But now we need to find the mass of vanadium that is being produced. So now we come and say, well, the number of moles of vanadium will be equal to the mass divided by the molar mass. So now you can say, well, 200 is equal to the mass, and the molar mass of vanadium is 51. Then from this point, you simply cross multiply. And let's see how much do you get when you say 200 times 51. Well, you simply get 10,200 grams. So this is the theoretical yield, which is nice. So what? Well, now it's time to find the percentage yield, which is our step number 4. Well, you come and say the percentage yield is equal to the actual yield divided by the theoretical yield. Of course, you write it in full, right? I'm just exercising the benefits of being a tutor. Don't need to write down everything if you're a tutor. But of course, if you're a learner, it's terribly important. You write as if you're writing for someone who doesn't know physical sciences. That's the best way to write. So, yeah. Okay, fine. So now we come and say, well, what we actually obtained is 8.67 times 10 to the power 3. And this is divided by 10,200. And we times the entire thing by 100. So let's see how much we get as our percentage yield. Well, we find that the percentage yield will be a solid 85%. Over and out.